we'd like to talk about slope and how it relates to physics. And you'll see this come up, the slope come up quite a lot, because in one of the things that we talk about in physics is rates of change. And anytime we talk about the rate of change, that is a slope. And so you'll see this come up when we talk about position, and the rate of change of position is the velocity. You'll see it come up when we talk about velocity, and the rate of change is the acceleration. So you'll see it come up in kinematics. You'll see it come up in our discussion of potential energy, and you can see it come up in other topics as well as you advance through physics. You may have heard of slope being defined as the rise over the run, and that's a really useful mnemonic to remember. Of course, what this is the change in the vertical component over the change in the horizontal axis. Or in other words, this is y final minus y initial divided by x final minus x initial. So let's look at our three types of graphs that we have in physics. The first one is the constant graph. And as you might guess, it's constant, right? So our change in y is 0. It stays right here all the time. Well, then if we looked at our slope, our slope is change in y over change in x. Change in y is 0. Change in x can be anything we want, as long as it's not 0. And we will get a slope equal to 0. So if our slope is 0, if our graph is constant, our slope is 0, and anything that depends on that slope will also be 0. Our linear graph ends up still being pretty simple. If we looked at our straight line graph, we can look at 2 points, right? Maybe this point right here and this one right here. And we can calculate the slope between those 2 points. We would say find where the first point is on the x-axis, find where the second point is on the x-axis, and that would allow us to calculate delta x. Then we would come over and we would find where the first point is on the y-axis, find where the second point is on the y-axis, and this would allow us to calculate delta y. And then the ratio of those two would be the slope. One interesting thing about this is this gives us the slope between any 2 points. If this were, say, the position versus time graph, then that would correspond to the average velocity between these 2 time points. But since it's a straight line, we know that we can pick any point on this graph, and it's going to have the same slope, the same tangent line. So if we drew a line through that point tangent to this blue line, it would exactly run along the blue line. And so for a straight line graph, for a linear relationship, then my average value is equal to my instantaneous value. So in this case, if we said if our slope was our average velocity, then that is also equal to my instantaneous velocity. Now this is only so long as this is a linear graph. The last graph is the most interesting, and that's the quadratic graph. We can look at 2 points, and we can use the slope to calculate the slope equation to calculate something between these 2 points. But what we will find we have done is we will have calculated the slope of a line that connects those 2 points, and it is this line. So that doesn't give us necessarily the slope at this first point or the slope at this second point, because we haven't really well defined what that is. Instead, it gives us sort of the average slope between those 2 points. What we can do, though, is we can think about it. We can make a thought experiment. What would happen if we brought this second point closer and closer to the first? Well, if I brought it, say, to here, I would make a new line that connects those 2 points. And if I kept doing this, I could bring it to here, and that would make a new line. And eventually I would get so close that I'm right on top of this first point. And I would get a line, and it's hard for me to draw that line, but I would get a line that is tangent to the curve of this graph. And that is then what we talk about when we talk about the slope at a point on a curve. It's really the slope of the tangent line that passes through that point. Now, this then gives us our instantaneous value. So if we have a quadratic graph, we have to do this moving the points closer and closer together to get our instantaneous value, or we have to look at some other method to get the instantaneous value. Now, to do this, that requires some advanced mathematics. And so we'll look at that, but if you're in a course that doesn't require calculus, then don't expect to have to know how to do this. Just understand that when we take the slope and we use the slope formula to calculate the slope between 2 points, we're not really taking the slope at a single point, we're taking the average between those 2 points. And we're getting this average line between them. So hopefully that gives you an idea of how to deal with the concept of slope and how it might come up in physics. We'll get lots of practice using this, especially when we're talking about kinematics. And so don't stress out too much about it, but try to understand how to use the slope, how to calculate the slope. It will come up in the course.